the alternating series test to decide whether the series is convergent or divergent. So first of all, we have the sum -1 raised to the n. So this is a characteristic, the -1 as a base raised to some n power. That is the characteristic of alternating series. And then the e to the n is my bn. So my bn is equals to e to the -n, which is 1 divided by e to the n. And then the next term, that bn plus 1, that is equals to 1 divided by e to the n plus 1. And then we have to make a comparison. When n is equals to 1, we have 1 divided by, let's do this. So first of all, we have to prove that the n plus 1 is bigger, right? So when n is equals to 1, let's put the bn plus 1 on this side. So 1 divided by e to the 1 plus 1. And then the bn, this is 1 divided by e to the first. Which one is bigger? So if you take a quick approximation, the bn plus 1 is smaller. So this is satisfied. You can do a quick approximation. 1 divided by e squared is less than or equal to 1 divided by e. This inequality is true. So number one, we just prove that the next term is less than or equals to the current term. So this is satisfied. Now, be very careful. Sometimes when you plug in n equals to 1, this won't be satisfied, but don't be panic. Try n equals to 2, n equals to 3. As long as when you increase the n, the first condition is satisfied, we can still consider the first condition satisfied. All right. So n equals to 1. Again, remember, sometimes you have to try one more n to prove that number 1 is satisfied. Let's move on to number 2. Number 2, you have to show that the limit as n approaches to infinity, bn is equals to 0. All right. So this is limit as n approaches to infinity. You have 1 divided by e to the n. So that is 1 divided by e to the infinity, which is 1 divided by infinity. That is equals to 0. So since number 1 and 2 are satisfied, this series is convergent. By what test? By the alternating series test. Okay, so let's take a look at number 2. So we have number 2, switch color for number 2. So number 2, we have the summation, n goes from 1 to infinity. So the first factor is the characteristic of alternating series. And then the bn is n squared divided by n to the third plus 4. Okay, so my bn is equals to n squared divided by n to the third plus 4. And then the bn plus 1, so you change the n to n plus 1 squared divided by n plus 1 to the third, and then plus 4. So first of all, let's test the inequality. When n is equals to 1, I can tell you right now the inequality is not satisfied. When n is equals to 1. So when n is equals to 1, we have bn 1 plus 1 is 2. So that will be 1 plus 1, 2 square. 1 plus 1, that is a 2 to the third, plus 4. And then the other side, b1, so this is equals to 1 square plus 4. So if you take a quick approximation, this is around 0.3333. This is 0.20. So we cannot say then this inequality right here, then this is not true. Then this is not true yet, right? So you cannot say 0.2 is greater than 0.3. So this is not true yet. When you encounter this situation, don't be panicked. Try one more. N is equals to 2. So we have 2 plus 1 equals to 3. So this is a 2 plus 1, 3 square. 2 plus 1, 3 to the third, plus 4. And then on the other side, b2, this is a 2 square, 2 to the third, plus 4. So if you do a quick approximation, this is 0.29, and then this is a 0.33. So now the inequality is satisfied. So number 1 is satisfied. All right. So when you see this situation, you can still try n equals to 3 and n equals to 4. So once this is satisfied, and you try n equals to 3, n equals to 4, and they will be satisfied. So number 1 is done. So number 1 is checked. And then number 2, you have to make sure that the limit as n approaches to infinity of Bn is equals to 0. So the limit as n approaches to infinity, the Bn is n squared divided by n to the third plus 4. So this one solving limit, what do you still remember how to solve this? You have to look at the highest degree in the denominator, and then you have to divide each term by n to the third. So on top, you have a limit as n approaches to infinity, square on top, third on the bottom, so that will be 1 divided by n, and then denominator 1 divided by 4 over the n to the third. So what happened in here? Once the n approaches to infinity, then you have a 0. You have a 0 divided by 1 plus 0. So overall, that is equals to 0. So number 2 is satisfied. Number 1 is satisfied. So therefore, this series is convergent by the alternating series test. All right. So before we end this video, I want to talk about the idea of these two concepts. Right. So first, you have an alternating series. So you have a B1 minus B2 plus B3 minus B4 plus B5 minus B6, so on and so forth. Let's put the B. Let's make the B look better. B5 and then minus B6 and then so on and so forth. So first of all, you want to show that the next term is the current term is greater than the next term. So number 1, you want to show that the next term is less than or equal to the current term, right? So what does that mean? That means when you, so for number 1 and 2, how about this? For number 1 and 2, basically you are analyzing the Bn only, right? So you are analyzing the Bn only. So what does that mean when you analyze the Bn only? That means you want to take away the negative. So you want to get rid of all the negatives since the negative is alternating. So you are looking at this B1, B2, B3, B4, B5, B6, so on and so forth. You want to get rid of all the negative. We are not considering the negative at all. First of all, you have to show that the current term is less than is greater than or equal to the next term. That means from B1 to B2, you want to see a decreasing pattern, right? You want to see a decreasing pattern. So maybe this is a 1, this is a 1/2, this is a 1/2, this is a 1/3, this is a 1/4, this is a 1/5, this is a 1/6. You want to see that the next term is less, the current term is greater than or equal to the next term. You want to see this. Why do you want to see this? Because the reason is, so here is how you explain number 1. As n approaches to infinity, you want to see that the last couple terms, this term, you are adding up zeros right there. The last couple terms, you are adding up zeros right there as n approaches to infinity. And then you want to show that these are actually 0, right? Because the pattern is decreasing. So as you look all the way to the right, the last couple terms must be 0. So that's why you need number 2. So I want them to be 0. That's why I need this limit. So as n approaches to infinity, the last couple terms, I want them to be equal to 0. So when the last couple terms are equal to 0, so that means you are only adding up a bunch of 0, meaning that the sum of the alternating series is determined by the first couple terms. So when the sum is determined by the first couple term, meaning that you are adding and subtracting a bunch of real numbers, as a result, the sum must be a real number. So therefore, the series is convergent. So that is the idea of alternating series test. All right. And then in the next video, I will show you a couple more examples of the alternating series test. So I will see you all over there. So if you think my instruction is helpful, please like, subscribe, and share the video. What do you think about this lesson? Let me know in the comment section below. I see you all in the next one. Signing out.